Hello, and hi to everybody that I met at Kickstart. I'm sure by now some of you will have seen my disc cleaning machine running in various other videos. If you haven't a clue what I'm on about, then you'll need to check out my previous video first. This cleaning machine ran absolutely solidly for the entire 2 days of Kickstart without any issues at all, and wow, did it draw a crowd. If not for the noise it made, then maybe for the sheer craziness of it. Oh, and I might have slightly annoyed Control-Alt Reese on the table next to me. Sorry, Reese. In this video, I'll show you the programming required to get it working, and a few issues I had along the way. And then, at the end, I'll show you a full demo. Feel free to skip to the end if that's what you came here for. So, let's start with the changes that I've made since the last video. Firstly, to keep it safe and to help me carry it to the event, it has its own flight case. This is actually meant for 12-inch vinyl records, but somehow it fits perfectly. Now looking at it from the front, you'll see I've added this cable tidy around the motor cable here. Some thumb screws to hold the lid on, although they never went back on after I removed them for the event. And round the back you'll see 3 new switches. The first, cleaning mode, will change between 2 different cleaning cycles. I'll come back to that later. The second, heaters, well, at the end of the last video, I had the 2 5-volt heaters connected in series across the 12-volt line, meaning they got 6 volts each. The heat sinks combined with the fans stopped it really getting warm at all. So, if we flip this switch, it connects both heaters across the 12-volt line. Now normally this wouldn't be a good idea, but with the heat sinks and the fans, the temperature of the air coming out feels just sort of warm, but not too hot. Last up, this button. Whilst developing the code, I needed to find a way to shut off the isopropanol supply, so that repeated tests didn't end up pouring all over the desk. It also came in really handy at Kickstart, because as the cleaning cycle was never finished and skipped, the cleaning heads never really got a chance to dry out. All this switch does is stops the pump from running. Next up, inside. Under the lid there's not really any change, but inside the box there's quite a few differences. The biggest you'll notice is the big tank that's full of isopropanol, and being a nice Tupperware container, it's also airtight sealed too. There's also a few extra power wires here and there just to make it easier to open the lid. There's obviously wires for the new switches on the back, and I've stuck the relay block onto the side of the box rather than it just floating around at the bottom. There's one other real minor change, but I'll cover that later. If I'd given this contraption to you and said, make it work, I suspect you'd find it difficult knowing where to start. However, if we break down the required functions, it becomes much simpler. So where did I start? Well, I thought the motor controlling Arduino was probably going to be the easiest to get working first. I wanted to be able to simply issue commands to it, and it received them and send a message back when it had finished. And I wanted to do this using the Arduino's built-in serial port. So, let's start with the motors. This project uses the Arduino AccelStepper library to control all of the motors. It's a little strange to use and the documentation isn't great. Thankfully, this page on Hackaday called AccelStepper, the missing manual, goes into a lot of detail. But once you get the hang of it, the library is actually quite simple to use. I created variables for each set of the motor pins here. Then, the first thing I would need to do is initialise everything properly. The various numbers you see here for maximum speed and acceleration were based on trial and error. If you set these too high, the motors wouldn't actually turn because they'll probably stall. As well as setup, I wanted a function that would just stop everything. The disable output function is actually really handy. It basically turns off the power to the motor while you're not using it, and it helps reduce the load on the 5-volt converter inside the box. Aside from this, on startup I don't want the Arduino to do anything else, as there's no control over the servos with the cleaning brushes on them. If it tried to move the disc holder along, it actually might hit those cleaning heads and damage something. The easiest way to make a system like this is to use what's called a state machine. The idea being the system is in a specific state and only performs that one task. By putting the system into a specific state, it's easy to make it follow a specific program, i.e. when it's finished a specific task, it can change to the next state. So I defined a series of possible states, starting with it being in an unknown state, i.e. at startup. All of the commands are received via the serial port, each command being a single character, with mostly simple single character replies as well. The very first command I wrote was the reset command. This was designed to turn the motor on and move the disc holder along the track until it hit the limit switch on the end, and then move in the opposite direction a specified distance. Now that position wasn't calculated, I just kept trying and trying using trial and error until I got it positioned at exactly the right point at the start. I also made sure that no other commands were allowed to be executed until a successful reset had been completed. You'll notice that I also had some code here to detect a timeout too, just in case the motor stalled or something was in the way to prevent it reaching its target. I'm now going to send the reset command and you can watch what it does. First sending the X command and waiting for the reply of 1 to say it completed. It's now kind of weird watching it move around without any music. Perfect! So, because that ran, we now knew exactly where the disk holder was. And there's only really a few extra commands we need from here. One to start the cleaning cycle and one to start the drying one. Now the cleaning cycle, I had an idea. The first was to move the disk back and forth whilst rotating the cleaning buds, and each time it did this to slowly rotate the disk a little. I roughly calculated this would take about 5 minutes for one revolution. Very thorough, but very slow. So the second method was the main one I actually used, and it had a different approach. I moved the disk into place, span the disk at a more or less normal speed, and then for each revolution, it simply moved the disk a little bit. It only had to do this about 5 or 6 times to cover the entire width of the visible part of the disk as well. This approach was much faster, as you'll see later on. As for drying, well, we just needed to move the disk into position, further along the track, and then gently rock it backwards and forth. All of these positions, once again, I got from trial and error. The last command I really needed was one to go home. Kind of like the reset command, except it already knew where it was at this point, and as the AccelStepper library actually keeps track of the motor position for it, you just have to simply tell it where to go, and off it goes. Now there's a few other commands I added, but they're not really much interest. One turns the disk motor on, to help get the disk inserted and engage with the motor. During the cleaning cycle, I realised I would need to be able to report how far through it had actually got. Now I could have just used some sort of timer, but it seemed more sensible to add one further command to query this information. The cleaning cycle was already keeping a counter of what it was actually doing. This made making this command really easy. All I had to do was send that counter back. So let's take a look at that. We're already at the reset point, so I'll send the clean command. Now I probably have that motor spinning a little fast here. And then followed by the dry command. Note that it reverses the direction after a while. The order doesn't really matter, so I'll send the fast clean command next. Note that I accidentally typed the wrong command there and it was still perfectly okay. Finally, I'll send the command home. With the motor Arduino now doing exactly what I wanted it to do, I could more or less forget about it and focus on the other one. One of the trickiest parts was that I was running out of I/O pins and I wanted to use the serial ports of both Arduinos to talk to each other. But if you leave them connected to each other, you can't actually upload any new code to it. So, I temporarily rewired things while testing, and used pins that I wasn't using at that moment, and with the help of the software serial library to provide a virtual serial port, this mostly worked great. So, let's take a look at how the main Arduino controller actually worked. Just like the first Arduino sketch, you'll notice some familiar concepts. You'll see that I've defined all of the states the system could be in, and then I've defined all of the port pins. The Arduino ecosystem is great. You rarely have to write any code for any external piece of hardware. Even the MP3 player module has its own pre-written library to control it, waiting to be installed. Then there's the LEDs. These are all individually addressable, and I connected them all up in one long chain. And I chose to use the fast LED library to control them, the same one I used in my fake Fireflies project. And as I was temporarily already using the software serial library to communicate with the other Arduino, it was handy because I needed a second one for the MP3 player too. And then lastly, there's controlling the servos, and this is where I started to run into problems. The stock standard Arduino servo library doesn't play nicely with the fast LED library. They both share some of the same resources, and at one point this caused one of the servos to turn all the way around and snap off. So, after a little bit of searching, I found the PWM servo library, which can't control as many servos, but it can control them directly using the hardware. The pins I connected those servos on was no coincidence. But that wasn't the only clash I had. Whilst debugging, I was using the software serial library to communicate with the other Arduino. Well, it turns out the fast LED library also causes issues with that too. You see, that library needs very precise timing to send all the data correctly, and it does this by switching everything else off, which includes listening for data on a virtual serial port. Intermittently, I wouldn't receive reply messages from the other Arduino. I didn't need to fix this one however, as it was only a temporary problem while I was debugging this. So I created all of the LED animations and then disabled them whilst working on the rest. Just like the other Arduino, the first thing I needed to do was to set this one up, and this time I actually needed to run a reset cycle. The setup function started with the usual preparing all of the I/O pins and resetting everything to off, followed by calling my reset function. The first job of this, like the other Arduino, was to stop everything. This section of the code makes sure that the special command used to just make the cleaning heads spin randomly whilst not in use had actually finished. Then it turns all the LEDs off and powers up the servos. Servos are really great. You basically tell them the position to move to, and they do, and as fast as they possibly can, but they do use quite a bit of power. Theoretically, I don't need this calibration step, but it's just in case something moved, so I left it in. I started by moving the two servos to a position slightly off where it would actually end up, and way out of the way of the disc holder. Then I'm slowly inching them vertical until they hit the limit switches. Once they both reach that point, I power them both down. Next up, now that I knew the cleaning heads were out of the way, I could issue the reset command to the other Arduino and wait for it to run the cycle. Whilst waiting for it to complete, we put on a fancy light show. Now the fast LED library makes controlling these really easy. You basically end up with an array where each element represents the colour of each LED. Then you just call the show function and they magically update. Once finished, it turned all the LEDs back off again. Now complete, it returned to the remaining part of the setup function, where it triggers a startup sound before switching into the ready state mode. The state machine is actually executed in the main loop function. The ready state just animates a small white flash across the entire of the LED strips. When this flash starts, it sends a message to the other Arduino just to spin the cleaning head slightly, for fun. It's also monitoring the buttons too, and I wrote a little button handler to make it easier to manage. This function handles monitoring the state of all three buttons, along with debouncing the signals so we don't get duplicate triggers. A useful side effect of this debouncing is we also get to know how long a button has been held for, which I used in the ready function because I wanted you to have to press and hold the yellow button for the sequence to start, and depending on which mode we're in, it calls a different function. The button handler also has an on button down function that it calls. I didn't end up using this much, but it is used to toggle the mode while in the idle state, which in turn plays a suitable sound for each selection. I reckon a good majority of the code in this Arduino is just for frills. You know, the completely pointless bits, the light and the sound, and it was so worth it because it made everybody really smile. And that smile usually started with the cleaning process. The first stage in the cleaning process is to get some isopropanol onto those cleaning buds, so I created this function. The first thing it does is to open the solenoid valve to allow air to flow into the tank inside. Arm servos is a small function I added that simply moves the cleaning pads into position or back upright again, and again with a little bit of flair. I send the fun command to spin the pads again, the same function I use while it's idle, followed by turning on the pump for a short amount of time, once again with an LED animation. Then I turn the pump off again and trigger another LED effect. Finally, after this sequence runs 6 times, I turn off the air valve and run one more LED sequence. This fancy display cycles through like a rainbow, but it's actually a delay to allow any remaining drips to finish coming out. This function then exits by first retracting the cleaning pads back out of the way. The first time I ran this code, I got to this line. The whole thing went crazy and isopropanol started pouring out everywhere, and I madly was reaching around for the power cord. But it carried on pouring as the USB connection from the computer was still providing enough power for it to continue. Anyway, eventually after a small puddle had formed, I stopped it. I'd forgotten something very simple. The air solenoid is basically a big electromagnetic coil. It's powered using the 12 volt supply, and I wasn't expecting it to cause any issues, especially as the relays that trigger this already had protection. However, when you instantly turn off a coil like this, as the magnetic field collapses, you get a voltage induced in the windings in the opposite direction. This is back EMF, and it essentially caused a massive voltage spike which made its way down through the 12 volts to 5 volt converter, enough to cause both of the Arduinos to reset. But they also didn't reset properly either and got stuck. However, it's an easy fix once you know the cause, and as you can see here, all I had to do was add a simple diode, which essentially shorts out the back EMF signal, and the problem went away. I was smelling isopropanol for hours after that. Anyway, after that stage had completed, I then sent a clean or fast clean command to the other Arduino, depending on how the switch was set on the back. Now I have a special function for listening to responses from the other Arduino, and as you can see, it doesn't really do a lot. The only response we're really interested in is the seek complete command. This means that the motor has reached the desired position and has started doing whatever you told it to do, i.e. cleaning or drying, and in response to this we switch our state to match. Now the washing function is actually quite big, but once again, most of it is actually having fun with the LEDs more than anything else. This section monitors the progress from the other Arduino, requesting its position twice a second. At certain points during the drying cycle, it will also trigger, for a short time, some more isopropanol to come out, just to top it up, and then stopping it a short time later on. And as I said, the rest is literally just animating the LEDs in disco mode. That is until the blue abort button is pressed, or the mode button is pressed, or the current process has completed, which will then trigger it to either start drying or go home. The drying function looks like a simplified version of the cleaning process owing to the fact that all the work is actually being done on the other Arduino. Once drying is finished, it triggers the go home sequence and the thing is complete. I have a funny feeling that a good 75% of the code is actually just silly LED effects and sound, leaving only about 25% of it being useful. Bloatware in an Arduino, who'd have thought? Anyway, are you ready to see the entire crazy process? Now, the music it's supposed to play starts with the dance mix of the 70s car wash song by Rolls Royce. I'll be able to play a short bit of that, and then, once I skip to the drying phase, it plays Holding Out for a Hero by Bonnie Tyler, and there's absolutely no way I can play that for copyright reasons. So I've substituted it with a remastered MIDI file to at least give you a feel for what it was like. So, here we go, and I'm going to demo this just like I did at Kickstart, except without the disc so you can see what's going on. And I'm adding the music and sound effects in during editing so you can hear all the mechanical parts too. I'll start by powering it up. Once the reset process has finished, it plays a single sound. If you think you know what it is, then write it in the comments down below. First press on the mode button puts us into power down mode. Then we have 3 choices. We have
clean disk, dry disk, clean and dry disk.
So let's start it. Here you can see the isopropanol being pumped onto the cleaning pads. And then the cleaning process starts. Now we don't want to watch this all day, as fun as it might be, and it does take several minutes. So after cleaning, we'll want to dry the disc. And finally, when the drying process is finished, the disc is returned back to the start. And there you have it! A crazy contraption! And I still haven't actually tested a disc after it completed a cleaning cycle yet to see if it actually works. So, in the next video, I'll do some actual before and after reads and we'll check the results. Regardless of those results though, for me at least, if it doesn't work, it doesn't matter, because it put a smile on so many people's faces at the event, and we shared so many laughs together, and if that's all it does, then it's already made the project way more worth it than I could ever have imagined. So, thanks for watching, make sure you hit that subscribe button so you don't miss the actual test results, and I'll see you in the next one.